If you are currently leveling up your Django skills with this tutorial is part of a free YouTube playlist. The link to the whole playlist is in the video description. Now, if you love this tutorial and playlist, then you might also like to check out the whole course, Django Database ORM Mastery on Udemy. The link to the course, which should provide the best price, can be found in the video description. In this tutorial, we dive into the world of Docker networking. Whether you're deploying a single container or managing a complex application with multiple services, understanding Docker networking is crucial for ensuring smooth communication between your containers. Networking, Docker networking, is a big topic. What I've tried to do here in this presentation is to try and round up some of the more important concepts and underpinning knowledge of Docker and networking. We won't cover all topics, but it will be a good start. Now, I am making the assumption that you have some basic knowledge of Docker. We will work through some examples. I'm expecting you to have a basic understanding of what a container is and what an image is in Docker. Let's start with clarifying two of the most fundamental concepts in networking: localhost and 127.0.0.1, commonly called the loopback address or home address. The localhost or 127.0.0.1, they both refer to the local computer or device you're currently using. So it acts as a way for you to address your own machine on the network. So when you use localhost or 127.0.0.1, you're actually referring to your own computer's network interface. So why is this important? Well, let's just think of a basic setup. We have Docker, we have the Docker engine, so Docker installed on our computer. So let's just imagine that's a Docker engine running this box. And then typically we start a new container. Now remember, this is all running inside of our computer. Containers operate within network namespaces. These are isolated environments which, by default, we cannot access unless we configure access to the containers. So these isolated environments manage their network connections. So to interact with these containers, we have to do that through our network interface. Now let's remember this Docker engine and our container is running on our own machine, our local machine. So in order for us to interface or to connect, send messages to our container, we would need to do that through the network interface, which is on our local machine. Hence the need for a way for us to address our own machine. And we can do that by utilizing localhost or the loopback address 127.0.0.1. So simply put, when we're developing an application on our machine and we need access to the Docker container, we simply need to address it via 127.0.0.1 or by utilizing localhost. Now that we have the underpinning knowledge of localhost and loopback addresses, let's now talk about network ports and how they play a crucial role in accessing Docker containers. I like to think of ports as doors or entry points or channels through which data travels in and out of your computer or container. Each port can be identified by a number. So typically we have ports range from port 0 to port 65535. I like to visualize ports as doors or entry points or channels through which data travels in and out of your computer or container. Ports can be identified by a number, typically between 0 and 65535. Now, you may already be familiar with ports or utilizing ports if you have been developing in the Python ecosystem, web applications. You've utilized ports to access maybe some of the web services that you have active on your machine whilst developing. You may also know that we can't necessarily use all of these ports because some are reserved for certain services. So for example, HTTP, that utilizes port 80. If we utilize port HTTPS, the secure version, then that would use port 443. So there are reserved ports in this range here, typically above 1024 and onwards can be used, and typically anything in the range of 0 to 1023, those are typically the reserved range. Because, as I suggested, ports are entry points or channels through which data travels in and out of our container, we therefore need to understand how to configure ports on both our local machine so that we can map a local machine port to a port number which represents a container service within our Docker engine. So let's grab a Docker engine. So this is our Docker engine. So we have Docker running in the background. Now within Docker, we go ahead and we create a new container. And let's just say that's running Django. Now we run the Django server. Typically that server runs on port 8000. So we now have the Django server running in our container. What's important to remember is that when we run a Docker container, it operates within its own internal network, which includes its own set of ports. Now, to make a container service accessible from outside of Docker, we need to map its internal ports to ports on the host machine. This is done using port mappings in the Docker configurations. Like I said previously, ports help direct network traffic to the correct application or service running on your device. So if we can imagine this is our computer, what we need to do now is select a port. Now this doesn't have to be port 80. We can select anything maybe above 1224, and we can then assign or set that port. Let's just go for 8000 in this case. We can map that port to the port in the container. So let's just again visualize this port as some sort of a doorway, and this port here is 8000. So we're going to simply map the port on our local machine to the port over to the Django container. By doing that, we've now created a channel through which data can travel from our local machine to the container. Now that we have this mapping on our local machine, maybe through the browser, we can use 127 or the local host, including the port number, to direct traffic within our computer through the network interface over to the Docker container. Now, as I alluded to before, you don't need to match the port numbers, the mapping, from the local machine to the container. So here, for example, we could use 8010 or 8012, 16, anything over 1024 port in order to map across to the port 8000 in the Django container. Let's see an example of this here in Docker Compose. We have a database service and add miner, and you can see that we have defined the mapping of the ports. Now on the left hand side here in specifically Docker Compose, this is the local machine host port. So the port on the local machine or host, that's the first portion, and then the second portion, that's the container service. So this is the port inside the container that we want to expose and send traffic to. Now it is slightly different, for example, if you're using the Docker API, which follows a different convention for port mapping compared to how you would set up on Docker Compose. It's completely the opposite way. So first of all, it's the port on the container, and then that's the mapping across then to the host port on your machine. Okay, so to summarize ports, network ports, these are channels used to direct network traffic. Docker port mapping, so we need to map container ports to host ports to make services available. Remember, we can't access the service until we open a port. And then accessing services, we're going to be utilizing the host IP address or the loopback address 127 or localhost with the mapped port to access containerized applications. So let's talk a little bit about the default network settings. We have already covered some of these already, discussing network ports and the local host, but let's just establish a basic understanding of what happens when we start a Docker container, some of the default network settings. So let's talk a little bit about the default setup whenever we were to, for example, start a new Docker container. So we have our Docker engine. So what you might start to do is start to create a few containers. So let's imagine you were to utilize the command line to create a few containers. So let's say you created 3 containers, 3 individual containers. Now the default here, or the default network in Docker, is to assign these containers to the bridge network. So when you run a container without specifying a network, it connects to the bridge network. So this is ideal for standalone containers that potentially need communication between each other. So we've established that the default network is a bridge network for standalone containers, but this is managed differently when using Docker Compose. Now I've started to use this common terminology, network scope, and that really just defines the boundaries of a network. So here we have the default network for the standalone containers, a bridge network, which, like we have already established, means that they can all communicate with each other. Now here, utilizing Docker Compose, or when you create a Docker Compose project, the default network is scoped to that Docker Compose project, and the name of that network is then based upon the project name. Now you can see in this example at the top we have an individual container, our test DB, and then we have a Docker Compose setup, a container stack here with 2 containers. So the default settings in actual fact would prevent the containers here in this Docker stack from communicating with the test DB, because both of these are in different network scopes. Now let's go ahead and inspect a container in both of these networks, and this might help also identify or better define what we mean by network scope. Now if I move into inventory and inspect, at the bottom you're going to find the network information, and you can see here that this network, or this container, sorry, is part of the Django Commerce default network, and how it's generated that name partly is through the project name, Django Commerce. Right, so in addition to that, what you can see is that we have a gateway and we have an IP address. Now notice that the gateway is 127.18. This is a Class B IP address, and we have an IP address of 127.18.03. That's the individual IP address where we can send information to this particular container. Now, if I go back to, remember 127.18, so if we go back to the test DB, which is on a separate network, it's scoped, different network scope. Let's go over to inspect. Let's go to the bottom here. You can see that, yeah, again, it's using a bridge network. And this time you can see the gateway is 127.17, and it has an IP address of 172.17.02. So in actual fact, when we say they are scoped, they have a different network scope, we could more specifically say that each Docker network is logically isolated from others, meaning containers on different networks cannot directly communicate with each other unless explicitly configured to do so. So each network has its own IP address range. For example, here you've seen the address range 127.17 on this individual container, and then 127.18 on the Docker Compose stack. Now, in my opinion, every full stack developer should understand the basics of IP addressing. So let's just go through the basics to really establish what we've just seen there in the Docker configuration. And that should then give us an understanding and explain why we cannot connect without intervention between different network scopes in our Docker environment. So there are 2 versions of IP addresses, IP version 4 and IP version 6. So we're just going to be talking about IP version 4. IP addresses are categorized into different classes based upon their ranges and usage. So in actual fact, we have class A, B, C, D, and E, but really we just need to focus on class A, B, and C. Right, so each class has a range. So you may have already seen an IP address. We've already looked at one previously. The IP address at version 4 is separated into 4 portions, 4 numbers. These numbers can range between 0 and 255. Now the reason why that is because each of these portions here, each of these portions is 8-bit. Now with 8 bits, we can then generate up to the number 255. So class A has a range of 0000 to 127.255.255.255. So anytime you see an IP address, an IP version 6 address that's between 0000 and 127.255.255.255, you know it's going to be a class A IP address. Now let me just move that across slightly so you can see. Now, for those who know a little bit about networking, you may be thinking I made a mistake here with the class A range, because in actual fact, this 127 should really be 126, because if you remember, 127.0.0.1 is the loopback address. So in actual fact, that IP address is part of a reserved range, a loopback range. So the entire 127.0.0.1 to 127.255.255 range is reserved for loopback addresses. This means that any IP address within this range is used for local testing and communication within the same machine. So in actual fact, none of the 127 range will be assignable to a network interface. So we couldn't assign that to a Docker container, for example. So you can see that the class B network has a range of 128 to 191. And then the class C network will have then a range of 192.0.0.0 all the way up to 223.255.255.255. Now with that information, we can start to actually understand why this default bridge network, the test database container, cannot connect to our Docker Compose stack. The reason being is that they are both assigned to different networks. So let's see if we can explain that. So here in the test DB at the bottom, if we inspect at the bottom, we have a range, or we have an IP address of 127.17.02. Okay, and then in the containers, in the Docker Compose stack, we have 127.18. If we take a closer look at the IP classes in IP version 4, they're broken down into 4 portions. In class A, what we have is a way of separating the network portion. So this is considered the network portion, and this here is the host portion. So this number here in the first portion, the network portion, that's a number that's referring to the network. So that's if you, for example, live in a country and you're familiar with the local telephone system, this is how I used to explain it. Here in the UK, we have this number before the local number, so 07214. So we have this local number, and then we have the actual telephone number, so 321321. Okay, so a telephone system would be broken down like this. And the reason for that is that this number here would identify a location in the UK to send that traffic. Remember, we're trying to call someone on the plain old telephone system. Now, this number here is then going to be individual to that particular person's telephone. So this way allows us to send network traffic first to the local area, and then once we've found the local area, we can then go ahead and forward the traffic to the individual user. And of course, that makes it easier to divert that traffic to where it needs to get to. It can speed up the process rather than looking for everywhere over the UK just for this number here. So we can take that premise into what we're talking about here. We have a network number, so we can roughly work out where to send that data first. And then we can start to, within that network, think about finding the host user with this number here. So what you end up with is a number, 4-portion number. The first portion identifies the network that the host is on, and then the next 3 will identify the actual host user. Now in a class B and a class C, it's very similar. So with class B, the first 2 portions in actual fact are the network portion. So this is the network portion. In class C, what happens is that there's just more network portions. So this is the network portion. There's only one host portion in a class C network. So let's not worry about that. Let's stick with the class B because you may have already identified in the Docker container, we are using a class B network. So if we were to inspect the containers once again, the first container, the testDB, which is an individual standalone container, that is working on 172. I think it was 16. My apologies. In actual fact, it's 127.17. So we have the individual container on the 172.17 network, and then the compose containers on 172.18. So simply put, if you have different hosts on different network addresses, in this case we have network 172.17 and 172.18, they won't be able to communicate with each other unless otherwise specified through Docker configuration, or in a network scenario, you would require a level 3 device or a router in order to bridge between these 2 networks. So let's summarize the rules of engagement connecting between 2 host machines. So if this was a local network, we need to make sure that these devices have an IP address which is on the same range. Okay, so that's class A, B, or C. In addition to that, let's imagine let's say it's class B. If it's a class B network, then the first 2 portions of their IP address, the network portion, they need to be the same on both machines. And then similarly, the host portions, they need to be unique on both machines. They can't be the same. So let's give this machine on the left-hand side here 127.18.1.1. Now to make a connection between this machine and the machine on the right, we need to make sure that the first 2 numbers, the network numbers, are the same. And then we need to make sure that the host portions are different, so 1.2. In order for us to connect to any other network, so let's imagine we had a class A network here of 2.4.3.1. So we had a machine with that IP address. How we would connect to that is that we would need to configure, in our case, Docker, to bridge across to that network, or else, like I said, in a network scenario, we would need some sort of router device, and this device could then forward traffic to this network. Now, there is a lot of information there, and maybe you won't remember everything we've said there and introduced. It is a stepping stone into a much wider picture there, but hopefully that's given you enough information. So maybe you experience a problem of connectivity between containers. You can kind of draw upon that information, or having seen that information initially, and think to yourself, well, it could be potentially an IP address issue that you need to resolve and configure. Going from very specific information to now a little bit more abstract, let's talk about some of the types of Docker networks, because you don't have to be a network professional to work with Docker networks. Docker can do much of the lifting for you, having a little bit of knowledge of some of the built-in tools that Docker has to allow you to set up different types of networks. Docker provides several networking options to meet different use cases. We have already seen an example of the bridge network. So we have the default bridge network. So anytime we start a new container, it will be assigned to the bridge network, the default bridge network, which means that every container here will be able to communicate with each other. Now, what we can do is we can set up our own bridge network. So we can set up a named bridge network, which means that we can then assign that network to that container so that any container that's been assigned to that bridge network can communicate with each other. So you can go ahead and have a look at this in action. This is an Nginx container we're building here. So we're running Docker and we've named the container container1, and then we've assigned it to the network bridge. So if you run this and then go ahead and change the container name to, for example, container2, run that, you'll then have two containers running, and you can go ahead and inspect the network. You will find that they will be on the same network address range. Thus, they will be able to connect and communicate with each other. So the next mode that we can assign is the host network. So using the host network mode in Docker means that the container shares the network stack with your host machine. So this can be useful for performance-intensive applications. So when you run a container in the host mode, the container uses the host IP address and ports. The container does not get its own IP address. So there's no network isolation here between the container and the host. The container's network traffic is treated as if it's coming directly from the host machine. So like I said, this can be beneficial for applications that require high network throughput or low latency, as it does eliminate the overhead of having to actually translate or direct the traffic into the container through network address translation. Now, before you start spending hours trying to work out why host networking is not working, you need to remember to actually enable it. So in the settings, in the features in development, you have an option here, enable host networking. You will need to be logged into Docker Hub in order to enable that. Once you've done that, you can successfully utilize host networking on your machine. So let's give it a go. We're going to run a Docker Nginx container. So we're going to name this container1 network, and this time we're using host network option and then the Nginx container. So let's go ahead and run that. And then here on the Mac, I can just run a curl over to localhost, and you can see that I'm then returning the Nginx default homepage. If you can't use curl in your terminal, then just head over to your browser, type in localhost. That should open up the welcome to Nginx, just confirming that your container is working on host mode. There's no need to map ports here. You may have already noticed that. You can simply just access the server as if it was running locally on your machine. Okay, so next up is overlay network. Now, overlay networks in Docker are a powerful feature designed for multi-host communication, which is particularly useful in environments where you need to scale applications across multiple Docker hosts. An overlay network is a type of Docker network that you create and configure according to your needs. It allows you to define your containers, or how your containers should interact with each other and the rest of the network infrastructure. So unlike, say, a bridge network, so imagine we're running Docker on our machine, we have a bridge network, these can then all communicate with each other. Here, utilizing an overlay network, this spans across multiple Docker hosts. So you may have Docker running, for example, on a VPS somewhere. So this means essentially what we now do is have a much broader, bigger network which spans multiple Docker networks. Or should I say spans multiple Docker hosts. And then finally, we have non-network. So if we want to completely isolate the container from any network, maybe for security purposes or when networking is not needed, that is possible. To run that, we would simply need to define network none when running the container if utilizing the Docker command in the terminal. So far, we have been utilizing Docker in the terminal. Let's focus now on Docker Compose, take a look at how we might create, add containers to a custom network, a little bit about Docker DNS, and then finally how to assign Docker IP addresses to individual Docker containers. So let's kick this off by creating a custom network in Docker Compose. To make it a little bit more interesting, I thought that I would create a very simple example where we might need to utilize these new skills that we're going to learn, creating Docker networks, assigning them to containers, thinking about potentially applying static IP addresses to our containers. In the Docker Compose file that we have been creating thus far, we have a Postgres container, and we have also a container for the adminer tool, which is a user interface which allows us to interact with our Postgres database. Right, so far we have two containers, the Postgres container and the adminer container, whenever we run the Docker Compose file. Now, what we know so far is that when we create these containers within Docker Compose, they will be created and these containers will be able to communicate together. They will be assigned to the same logical network. What we've learned so far is that when we create two or more containers using Docker Compose, they are automatically placed in the same default network unless we specify otherwise. So this network allows the containers to communicate with each other using their service names as host names, which is convenient for service discovery within the Docker environment. So by default, Docker Compose creates a bridge network for these services in the same Compose file. This enables, like I said, seamless inter-container communication. Now, what we also have here is we are creating, using the Docker API, a container for our test database. Now, when we create this test database, it will be assigned to a different network. So that will mean by default, our test database won't necessarily have access to the Postgres and the adminer container, which is probably what you want to achieve anyway, but we're going to make this into a problem. As you start to develop and learn how to create these test databases, run tests, sometimes you might like to inspect the test database. Just maybe a little bit of sanity checking. Maybe there are issues or problems with how the test database is being generated or the data is being created within our test database. So we may want to actually delve into the test database at some point, and we might use tools such as adminer to actually connect and to inspect our test database. Now, the problem we have at the moment, if we try to utilize the adminer tool to connect to our test database, it's not going to be easy to do that because the test database is on a completely separate network. So our first task is to build a new network, a named network. So we're simply going to build a new network configuration or define a new network, and then we're going to assign all of our containers to that same network. And by doing that, of course, we then have inter-container communication. There are, of course, a few different considerations for us to consider before we do this. What type of network would we like to create? I think in this scenario, a bridge network would be suitable because that would then essentially allow all of the containers to be within the same network scope for us to allow easy communication between the different containers. So let's jump back into our Docker Compose file and let's go ahead and build our new network. So after the name, let's go ahead and define a new network or networks. And then inside of here, if I can just zoom in slightly, let's create a new network. So we're going to give this a name. This is going to be the dev network. And then we need to define the driver. So the type of network, which is going to be bridge. Now, by default, we don't need to define any IP addressing or any other configuration. And this is one of the benefits of utilizing networking in Docker. It is seamless. It does a lot for us in terms of actually setting up the network behind the scenes. We simply need some very basic configuration to actually build our own bridge network. So now what we need to do is assign this bridge network to our containers, which is really simple. We just need to add the network to the container. So this is going to be called the the network's called the dev network. So we can simply copy and paste that to the two containers. With that done, let's take a look at how that looks. So we're going to need to make sure we're in the right directory. I somehow don't have my keyboard. There we go. So we're going to need a Docker compose up with the D flag. Let's give this a go. So it looks like we have additional property, network is not allowed. Okay, so let's take a look. Networks, dev network driver, looks good to me. Now, this doesn't necessarily look very easy to resolve, but in actual fact, what I've done here is I've simulated the most common problem I see with students, and that's to forget the S, the plural, the fact that it's not network, it's network. So that's what we need to define. So here we have specified correctly networks with the S. So that is what we also need when we actually supply the network, define the network within the container setup. So it is networks, not network. Right, so with that in place, everything should be good to go. And now when we move to the containers, let's take a look and inspect. Move right to the bottom, and then what we'll see here is the dev network. Now what's important to note here is the actual name of the network. So we have Django e-commerce. Now that is derived here because we specified the name of our project, Django e-commerce. And then just note there is an underscore which separates the name of the project and the dev network, which is obviously the name that we supplied in Docker Compose, the name of our network. Now that's important because that is the name of the network that we need to supply if we are going to attach our network from the Docker API configuration that we created here to set up our test database. So head over to the test database container if you have this available file. And then just underneath the health check here, let's go ahead and define our network. So we're going to specify network mode in this case, and then we need to specify the name of our project, Django e-commerce dev network. So that's the name of the network we want to attach to. So with that set, let's now cd into our project and run Pytest. If I go back into Docker Compose, the test database should now be available. It does specify it's running and ready to run the tests. All the tests have run successfully at this point, but that's irrelevant. Let's just go into our test database. Let's inspect. At the bottom here, let's just see, and you can see that it is actually applied or assigned to the same network. So this has an IP address of 127.18.04. You'd imagine that the other networks would have a similar network IP address range. So this is 02, and you'd imagine then this inventory DB would have, will be number 3. Down, yep, so 03. So they are all in the same address range, which obviously is a requirement for us to then communicate with within or between the different containers. Now that we have all the containers within the same network, it means that we can easily connect the adminer tool to the test database should we like to do any sanity checking, or maybe there are some errors that we need to try and resolve and you might like to log in or access the test database. What you will need to remember is that we created the test database within our Docker Compose file, and we're simply attaching this test database to the network. Now, of course, if our Docker Compose file where we have defined the network, if we're not actually running those containers in that network, then of course our test database will fail. So this is really just an example of showing you how to attach to the network and potentially how you might like to attach your test database to the main network so that you can utilize the adminer tool to inspect the database. And we will be utilizing that within this course, just like I said, as a sanity check and for us to actually inspect the test database to get a better idea, gauge of what exactly is happening when we're running some of our tests. So that was a simple example of creating a custom network and adding containers to our custom network. So next up, let's talk a little bit about DNS. If you're not familiar with DNS, it is an important tool, not only here within the Docker environments, but in general on the internet. DNS, or domain name system, is a fundamental protocol on the internet that translates human readable name domains like example.com into IP addresses. So this is why and how we can actually type in simple domain names and for them to actually be resolved to some sort of website. But behind the scenes, what's happening is that DNS is acting like a phone book for the internet, allows users to access websites and services using this easy to remember name. And then behind the scenes, that's then being translated to an actual IP address. And that IP address is then actually being utilized to route to the service. There we go. Because on the internet, it is a fact that routers and these devices that move your data, move your requests to the actual service that you're looking for, they cannot utilize names like example.com. They utilize IP addresses. So the IP address is required in order for you to actually access the service or any service online or any network. So here in the world of Docker, the Docker DNS automatically provides service discovery for containers within a Docker network. So each container is assigned a host name. So we have, for example, 3 or let's just say 2 containers. We have the Postgres container, we have our adminer container. So what's happening behind the scenes then, like I said, is DNS or Docker DNS is automatically providing or assigning a host name to each of our containers. And this host name can then be easily utilized to match services within this environment. So if I wanted to, for example, connect the adminer tool to my Postgres database, which I would do regularly, if we didn't have the Docker DNS system in place, we would need to know the IP address of the Postgres service. So when I configure adminer to connect my Postgres to my Postgres container, I would actually need to supply some sort of IP address. But that's not the case. So because we have the Docker DNS service behind the scenes, I simply need just to define the name of the Postgres service. And then what happens is that name then gets translated into an IP address, which can then be used to route the traffic over to the Postgres container. The point being here, like I mentioned, it allows us users to access our services, our containers, using easy to remember names rather than numerical IP addresses. Now I mentioned the host name, so each service is provided a host name which can then be utilized. Now the host name is going to be generated from the service name. So let me just show you an example. We're going to use adminer now to access the inventory database. We do have the containers already started, I believe. Yep. So let's go into adminer. So we're going to need to utilize port 8080. So in the browser, I've typed in 127.0.0.1:8080. So like I said, because we have the Docker DNS automatically provided and running, we will need to type in the service name. So we could type in an IP address here of the database we want to connect to, but we don't need to. We can utilize the assigned host name or the service name, which is inventory.db, password Postgres, and the password Postgres. We should be able to log in. We refuse because I need to select the database that we're utilizing, and you can see we can easily then log in. So we've now seen the Docker DNS in action, just to show you that we can also use the IP address of the container. Now the Postgres database is running on 172.18.0.3 in my case. Yours might be slightly different, but I type in the username and password and you can see that I can log in as per usual, just utilizing the IP address. Thus just really demonstrating the fact that the DNS service is translating that host name that we did type in originally to the IP address to access the service as per normal. So to summarize there, DNS is a fundamental protocol on the internet utilized here in our Docker environment, which allows us to translate human readable domain names or service names into IP addresses, which are required by the computers to locate and communicate with other networks or other services on the network. So last but not least, assigning Docker IP addresses to a Docker container. Now, there may be occasions where you would like to actually add a static IP address to your Docker container, and this will provide a consistent network identification. What we've seen so far is that when we create our containers, they will be applied or assigned to some sort of network, and Docker will also assign an IP address to your container. Now, if we were to actually stop this container and restart it, the chances are potentially that we would be assigned a different IP address to this container. And now there may be some scenarios where you would like to ensure that this container, for example, is always provided the exact same IP address. And therefore, we would then set up a static IP address, define the IP address within our configurations. Now, one of the drawbacks, to start with the drawbacks of this approach of assigning a static IP address, is it reduces flexibility. It does bypass the Docker's dynamic networking capabilities, but ultimately it will work the same as if Docker did assign that IP address to your machine. So what is important to remember is what we learned about IP addresses, IP address ranges. So that when we do apply a custom IP address, we need to just make sure that we are applying the correct IP address for that particular network, which allows your container then to communicate with the containers that you wish it to do so. So just be careful that when you are assigning IP addresses, you do it correctly. You are assigning the correct IP address to your machine to make it available on your network. So when might you like to actually assign an IP address? Well, there are, I guess, a few different occasions when you might like to actually assign your own IP address or a static IP address to your container. Take, for example, when your application needs to communicate with external systems that are configured to allow traffic only to or from specific IP addresses. Static IP addresses can also be useful in multi-container setups where certain containers must always be reachable at a specific address. So let's jump back into the Docker Compose file. Let's now extend this network to include our custom network range. So IPAM, config, and then we can now define our subnet. So here we're going to create a class C network, so 192, and then 168.0. Now remember, class C networks have 3 portions or network portions. So that's our network address, which means that every machine that we assign to this network must have or be assigned those numbers there in that order. And then what we need to do here is we need to create our subnet. So we're going to add 0. That's going to be the network address. And then we need to actually define the number of, or should I say the subnet mask, which determines the range of IP addresses within the network. So here we're going to utilize 24 bits. I haven't explained this at all yet. So this means that the first 24 bits of the IP address are fixed. That means that these numbers here are fixed in every single address that we're going to assign within this network. And this number here, that's going to be the host portion here in our Class C network. So we're going to assign a unique number to every single container that we connect to this network. So like I said, I haven't mentioned subnet mask before. So just as a quick recap, if you remember, we have Class A, B, and C networks. Each class have a different amount of host and network portions. Okay, so Class A has 1 network portion and the rest are host portions. If you remember, Class B has 2 network portions and 2 host portions, and the Class C has 3 network portions and 1 host portion. There we go. So remember, each part here of the IP address is 8 bits. So what we're doing here, we're setting a subnet mask. So we're saying that the first three portions are going to be the same on every IP address that we assign. So 8, 16, 24. So 8, 16, 24. So this is going to be a /24. That's the network portion. And then, like I said, the host is going to be unique on each container. Now, if we chose a class B, what we would do there is we would assign a /16 because we have two parts of the network. If we choose a class A, we could by default just use the subnet mask of /8. So there is a lot more to subnet mask, which we haven't explained here in this short tutorial, but it is an important factor when you start to think about subnet masking or subnetting, sorry, your networks, which is a more complex type of setup that you might choose within your networks. So we're keeping it simple here. I say simple, we are keeping it simple and just utilizing the default 24 bits to define our subnet mask. Right, so with that in place, we now have defined the network. So we can now go ahead and actually assign this network to our containers. So we have already supplied the network name we want to connect to. So now we can just define IP version 4 address, and this is going to be 192.168.0. That's our network, and then we need to assign an IP address. So it can't be 0, and ideally it can't be 1. We want to start with number 2. So let's go for number 2, and then we can do exactly the same thing. Let's just indent that. Let's do the same thing for our second container. And this can be number 3. So the reason why I didn't use 01 is this address is typically used as the default gateway or network address for the subnet and should generally not be assigned to individual devices. So 192.168.0.0, so that, apologies if I've said that incorrectly previously, that's our network address. Okay, that's just called our network address. And then 192.168.0.1, in our case, that's going to then be reserved for the default gateway or the router's IP address for the network, serving as a point of access for maybe external networks. And then we also do have a broadcast address on here. So that would typically be 192.168.0.255. So typically with a class C, we're going to have 254 usable IP addresses. Now, just before we set that up in actual fact, let's just make sure that we have set this up correctly. So networks, dev network, we are going to need a colon, and let's indent that across. Now let's see if we can start this up. So it must be a string. Okay, so let's remove the dash. Get this right. Start it up again. There we go. So with the containers now running, let's just go ahead and inspect. We can view the custom configuration. So we have the Django e-commerce dev network. We have the IP address assigned to the gateway. Notice that it has been assigned to 01. We have an IP address of 02. That's what we have supplied within our Docker Compose file. So I have mentioned gateway, so I'll quickly summarize what the gateway is. So in Docker, the gateway refers to the IP address of Docker's network gateway device, which serves as the access point for containers to communicate with the external networks. So if you imagine, we have our Docker network here, we have our container, whether that be your Postgres database or maybe the adminer container. Now, in order for us to actually enter this network, there must be a point of access. So that point of access is going to be provided some sort of IP address. So in this case, we saw that it is provided 0.1. That's the address of our gateway. So think of the gateway as a gate, the gate into our network, the gate out of our network. So we would send traffic to that point, and then we can then enter this network and access the service. If this service required any external access, then it would send data to this gateway, And from there, it can then be sent across to wherever externally. So as we have seen, Docker does automatically configure this gateway, but we can also specify custom gateway addresses in more advanced network configurations if needed. So I do hope that was a good start to networking in Docker. I know we covered quite a lot there. We did skim the surface of a few things. There could have been more examples, of course, there could have, but hopefully, like I said, that gives you a starting point if you were new to Docker networks or networking in general.